This question asks us to shift the cosine graph. So this is my original cosine graph, and this minus pi over 2 is a shift to the right 90 degrees or pi over 2. So I'm going to take this graph and I'm going to shift it 90 degrees to the right. So those positions should end up here. So our end position is going to be at 5 pi over 2. Our starting position is here. So there's our cosine graph, and I'm just going to highlight the cosine part of this graph. So it starts at 1, goes up like this. Now when we look at this graph, the amplitude of this cosine graph really is going to be the amplitude of the sine graph. So the amplitude is 1. This has no horizontal compression, so the b value is equal to 1 here. So the b value here should also be equal to 1. And the vertical positioning is going to be plus 0 here, so that plus d and that plus 0 match. So really the only thing is establish what the horizontal shift is going to be. So the only difference here then should be represented by horizontal shift. Now if I want to have a sine function, the sine function starts in the middle and goes like this. But when I've shifted the cosine graph 90 degrees, the starting point of my sine function is in the right point. Okay, so for part B, we can say then that the sine function that matches that cosine graph is just going to be sine x. And in fact, the conclusion we can make then is there's only a 90 degree shift difference between the two graphs. So cosine of x minus pi over 2 is equal to sine. Okay, we could also shift the sign backwards, so we can go say that we can say the sine of x plus pi over 2 is equal to the cosine graph. Okay, because if we shift the sine graph to the left pi over 2, we're just going to end up with a cosine graph. And these are two generalizations which can be very useful. In fact, these are what we call identities.